Good day, students. Today we're going to discuss Module 15, which is about mutually exclusive events. After watching this video, you are expected to illustrate mutually exclusive events and find the probability of mutually exclusive events. Let's have a pretest first for you to have an idea of what mutually exclusive event is all about. Read and understand the question carefully and write the letter of the correct answer for number 1, number 2, number 3, number 4, and number 5. Take note that you can always pause and play this video if you need some time answering the problem. Now let's check your work. This is the answer for 1, 2, and 3 for numbers 4 and 5. Did you get a perfect score? If not, it's okay, but you have to listen carefully to the discussion of mutually exclusive events. But let us have some recap first. Let us recall your lesson about union of sets and finding its probability by answering this problem. For number 1 and for number 2. Let's check if your answer is correct. This is the answer for number 1 and the answer for number 2. Did you get a perfect score? I hope so. If not, I would like you to watch again your VL number 14. To continue with our lesson, I would like you to answer this first. Could the two events A and B in the following situations happen at the same time? If yes, put a check in the box. If no, put a cross. For number 1, and these two events happen at the same time? How about number 2? Number 3? How about number 4? And number 5? Let's check if your answer is correct. Numbers 1, 2, 4, and 5 are events that cannot happen at the same time. Why is that? Because when you toss a coin and you get a head, you won't be able to get a tail as well. When you roll a die and you get a 1, definitely you won't be able to get a 6 anymore. When you get a yellow ball, you won't get a blue ball. When you selected John as the monitor, then you can no longer select Peter as the monitor. While in number 3, when you roll a die and get a 2, you also get an even number. That's why the events can happen at the same time. But in numbers 1, 2, 4, and 5, the events cannot happen at the same time. And these are examples of mutually exclusive events. But what is a mutually exclusive event? Two events are said to be mutually exclusive if both events cannot happen at the same time. These events have no common elements. Let's have the following examples. Illustrate and identify if the following events are mutually exclusive or not. For letter A, a card is thrown from a deck of standard playing cards. An ace is thrown, a king is thrown. Can these two events happen at the same time or not? Let us look at the illustration. Drawing a Venn diagram, you can see that A is different from B. They have no common element, and therefore, events A and B are mutually exclusive, since you can only get an ace or a king, but not both, and there is no element in common. How about in letter B? A card is thrown from a deck of standard playing cards. Event A, a heart is thrown. Event B, a king is thrown. Looking at the Venn diagram, you can see that there is a common element, which is the king of hearts. And once they have a common element, the two events can happen at the same time. Therefore, events A and B are not mutually exclusive or non-mutually exclusive, since the king of hearts is common to both hearts and kings. I hope I made the examples clear. Let's have another example. How about in finding the indicated probability? For letter A, probability of A plus probability of B is not equal to probability of A union with B. And we're looking for their intersection. Since they are not equal, it means that they are non-mutually exclusive. And to solve for that, we're going to make use of this formula. Probability of A union with B will be equal to probability of A plus probability of B minus their intersection. By substitution, by simplifying, by applying addition property of equality, by simplifying again, and by applying multiplication property of equality, we were able to solve for the probability of A intersection with B, and that is equal to 0.20. How about letter B? Probability of A is equal to 0.55. Probability of B is equal to 0.35. There is an intersection between the two events. Therefore, this is an example of non-mutually exclusive. So we're going to make use of the same formula, and by substitution and simplifying, we were able to get the value of the probability of A union with B, which is equal to 0.75. I hope I made this clear. How about in this example? In a hospital, there are 9 nurses and 4 physicians. 5 nurses and 1 physician are males. If a person is selected from the staff, what is the probability that the person is a nurse or female? How are we going to solve this kind of problem? I think a two-way table will help. Is this part of the given? No. You will be the one to make the two-way table. You can see that we have 2 kinds of staff, nurses and physicians. And there is a total of 9 nurses and 4 physicians. 5 nurses and 1 physician are males. Therefore, 9 minus 5 will give you 4 female nurses. 4 minus 1 will give you 3 female physicians. So we're looking for the probability that a person is a nurse or a female. Or means we're looking for the union. And therefore, we're going to make use of this formula because there is an intersection between the given data. A is represented by nurse, while B is represented by female. Therefore, the probability of getting a nurse or female will be equal to probability of nurse plus probability of female minus probability of nurse and female. The symbol of union was replaced with the word or, while the symbol for intersection was replaced with the word and. So by substitution, the probability of nurse, since we have 9 nurses in all, over 13, plus the probability of female, we have 7 females in all, over 13, minus their intersection. This is the female, this is the nurses, so the intersection is 4 out of 13. And by simplifying, we were able to get 12 over 13. So the probability of nurse or female is 12 over 13. I hope it's clear. The last example, 16 people study French, 21 study Spanish, and there are 30 altogether. Find the probability of people who study French only. To solve this kind of problem, we need to use some representation. Let B be the number of people who study French and Spanish. Let 16 minus B be the number of people who study French only. Why 16 minus B? Because there are 16 people who study French. So there are some people who may study French at the same time study Spanish. That's why we need to subtract the common element with 16 for us to get the number of people who study French only. Therefore, 21 minus B be the number of people who study Spanish only. There are 21 people who study Spanish. Subtracting the common element will give us the number of people who study Spanish only. Looking at the Venn diagram, we can clearly see that 16 minus B plus B plus 21 minus B will have the whole set, and therefore, we're going to make use of this equation. 16 minus B plus 21 minus B is equal to 30. Negative b plus 37 is equal to 30 by simplifying. Negative b is equal to 30 minus 37 by applying addition property of equality. And negative b is equal to negative 7 by simplifying, and we were able to solve for the value of b by applying multiplication property of equality. But since we're going to look for the number of people who study French only, we're going to substitute b with 7. 16 minus 7 will now give us 9, the number of people who study French. But we are looking for the probability. Therefore, it is equal to 9 over 30, or simply 3 over 10. I hope I made the example clear. To wrap it up, I would like you to remember that two events are mutually exclusive if both events cannot happen at the same time. These events have no common elements. Our probability of A intersection with B equals 0. We can use the formula probability of A union with B is equal to probability of A plus probability of B if they are mutually exclusive. And you're going to use probability of A plus probability of B minus probability of A intersection with B if they are not mutually exclusive, non-mutually exclusive, overlapping, or inclusive. I hope everything is clear. For our valuing, in your journal, I want you to reflect on this. I think you're ready for the pause test. Identify what is being asked and write the letter of the correct answer. For number 1, number 2, number 3, number 4, and number 5. Let's check if your answer is correct. I hope you made the perfect score. Good job! Now you're ready to answer the different activities in your module. For activity 1, for activity 2, and for activity 3. Let's check your work. Thank you for listening, and I hope to see you soon. God bless everyone.